Hello dear students, I hope you are enjoying the lectures of permutations and combination. Students, in our last lecture, we had studied till permutation. We had understood the meaning of the word permutation or arrangement of objects. Now, I will take up a few more examples and understand the word permutation in somewhat deep. And then we will move forward and understand what is the meaning of the word combination. What is the formula of combination of n distinct objects taken R at a time. Alright, so let's get started with the topic. Now that we are done with the permutations part, it is now time to move forward and understand combinations. The word combinations simply implies selection of objects which may be alike or different taken some or all at a time. In combination, order does not matter. Please make a note that in combination or selection of objects, order does not play a significant role. Unlike in the case of permutations where order of appearance of objects was important. So let's understand combinations with the help of an example. Consider that we have 4 objects A, B, C and D. And out of these 4 objects, we have to select any 2 objects. So if we are interested in understanding the combination of any 2 out of these 4 objects, this can be done in how many ways? I can have a combination like AB or AC or AD or BC or BD or CD. Alright, these are the total number of possible combinations of 2 objects out of these 4 objects that I can make. Now one must note that I haven't written BA along with AB. Also, I haven't written CA along with AC. Why? Because AB and BA in terms of selection are going to be counted as only one case, because I have underlined over here that order of appearance of objects do not matter in case of selection or combination. Alright, so how many total combinations of 2 objects I could have made? 1, 2, 3, 4, 5 and 6. So total there were 6 combinations. If we have to make a selection of n objects taken R at a time. So this can be done in how many ways? This can be done in NCR ways. This can be done in NCR ways. This is the total number of combinations of n objects taken R at a time. And NCR mathematically is equal to n factorial over n minus r factorial multiplied by r factorial. This is the formula of NCR, that is combination or selection of n objects taken R at a time. So according to this illustration, I had how many total objects? 1, 2, 3, 4. So the value of n was equal to 4. And out of these 4, I was interested in selecting any 2 objects. So basically value of R becomes 2. So according to the formula of NCR, we are going to write 4C2, and 4C2 upon calculation will give us 4 factorial divided by 2 factorial and again and 2 factorial. So this is equal to 4 multiplied by 3, 2 factorial divided by 2 factorial into 2 factorial. 2 factorial gets cancelled off and the answer comes out to be 12 divided by 2, which is equal to 6. And I have also shown you these 6 combinations are possible. We have written over here 6 combinations. So this is the formula of combination of n objects taken R at a time. Whenever I say combination, I am implying selection of objects. Alright, Now we have to understand that how have we arrived to this formula of NCR. Alright, let's understand this. In this case, when I had 4 objects and out of these 4 I have to select any 2. So you must have observed that if this is a selection AB, then when it comes to arrangement, there would be 2 arrangement. First is AB and second is BA. If this is a selection AC, then when it comes to the arrangement, there are again 2 arrangements, AC and CA. So corresponding to each combination that I have made over here, there are 2 possible arrangements, or I can arrange them in how many ways? 2 factorial ways. Alright, now suppose that you have n objects and you are taking r at a time for making selection or combination. We are going to make selection of r objects out of n, and upon selection we have to arrange r objects. Alright, and this gives us what? This gives us total arrangement. So total arrangement of n objects taken r at a time is given by, we have already studied, it is given by NPR. And NPR is equal to, first of all, selection of r objects out of n. Let us suppose that I am denoting this quantity by x. And then now, since we have done the selection, we have to arrange these r objects. Now r objects can be arranged linearly or in a row. In how many ways? R factorial ways. So the value of x comes out to be NPR whole divided by r factorial. And NPR, as we all know, is equal to n factorial divided by n minus r factorial. This is NPR. And over here we have one more r factorial. So I am going to divide this quantity again by r factorial. Alright, this comes out to be the value of x. And this x is what? Selection of r objects out of n. So this is what comes out to be the formula of selection of r objects out of n, or selection of n objects taken r at a time. And only this particular expression is expressed and denoted by NCR. So see, we have derived the formula of NCR. NCR is equal to n factorial over n minus r factorial into r factorial. So students, you are supposed to memorize the formula of NCR in order to solve the questions very accurately and fastly. I hope everybody must have understood the concept of combinations and the formula of NCR. Alright, let's move forward. So suppose we have 5 objects and we have to select 3 objects. So according to the formula, this can be done in how many ways? 5C3 ways. Because according to the given situation, value of n becomes 5 and value of r becomes 3. So 5C3 according to the formula gives us 5 factorial divided by 2 factorial and 3 factorial. So this is 5 into 4 into 3 factorial whole divided by 2 factorial and 3 factorial. So the net answer comes out to be 10. So there were total 10 ways in which selection of 3 objects can be done out of 5 distinct objects. Alright, so far so good. I hope everybody must have got this illustration. So now let's move forward and understand some properties of NCR. The very first property is NCR is equal to NC n minus r. NCR is equal to what? NC n minus r. For example, I can write 5C3 equal to 5C 5 minus 3, which is further equal to 5C2. So if somebody asks you what is the value of 5C3, is it different from 5C2? No, 5C3 and 5C2 are going to be same. Now let us prove how both of these quantities are equal. So in LHS we have NCR, and NCR, as we all know, is equal to what? NCR is equal to n factorial over n minus r factorial into r factorial. This is our LHS. And in RHS we have NC n minus r. So again over here I am applying the formula of NCR. So this can be written as n factorial over n minus r whole factorial multiplied by n minus r factorial in the denominator itself. Alright, I have just applied the formula of NCR, but here n minus r is replacing r. So this becomes n factorial divided by n minus r becomes r itself. So this is r factorial, and this can be written as it is n minus r factorial. So as we all can see that LHS over here is equal to the RHS. Alright, hence proved that NCR is always equal to NC n minus r. Let's move forward to understand the second property. Second property says that NCR plus NCR minus 1 is equal to n plus 1 CR. Now, how are we going to prove it? We are again going to prove it with the help of formula of NCR. Alright, so in LHS we have been given NCR plus NCR minus 1, which according to the formula can be written as n factorial over n minus r factorial plus n factorial over n minus r minus 1 factorial and r minus 1 factorial. Alright, so this can be written as n factorial divided by n minus r factorial plus n factorial whole divided by n minus r plus 1 factorial r minus 1 factorial. Alright, now see carefully that n minus r plus 1 factorial is going to be larger than n minus r factorial, and r factorial is going to be larger than r minus 1 factorial. So this can be further written as n factorial over n minus r factorial into r minus 1 factorial. I have reduced r factorial in terms of r into r minus 1 factorial. Plus next term can be written as n factorial divided by n minus r plus 1 and then n minus r factorial. Further we have r minus 1 factorial. Alright, I have reduced this factorial till n minus r factorial and this factorial till r minus 1 factorial. Now we have to take common in numerator n factorial, and in denominator we have n minus r factorial both the sides and r minus 1 factorial. And what we are left with is, over here I can get 1 by r plus over here what we are going to get? We are going to get 1 over n minus r plus 1. Alright, so now we have to take LCM of this expression. So it becomes n factorial, n minus r factorial, r minus 1 factorial, and in the numerator I am going to get the addition of these two terms, which gives us n plus 1, and in the denominator we get the multiplication of these two terms. Alright, now see that n minus r plus 1 when multiplied with n minus r factorial gives us what? N minus r plus 1 ka factorial, and r when multiplied with r minus 1 factorial gives us what? R factorial. In the numerator n plus 1 when gets multiplied with n factorial gives us n plus 1 factorial. So in all this becomes n plus 1 factorial divided by n minus r plus 1 factorial multiplied by r factorial. And one can easily observe that RHS over here will also be equal to what? N plus 1 factorial divided by n plus 1 minus r factorial and r factorial according to the formula of NCR. So basically we have proved that LHS over here is equal to RHS. Hence NCR plus NCR minus 1 is equal to n plus 1 CR. Alright, let's move forward to understand the third property. Now suppose we have been given that NCX is equal to NCY. NCX is equal to NCY. So this is possible if and only if either x is equal to y or x plus y is equal to n. Alright, why? Because I can write down from the previous property that NCY is nothing but NC n minus y, the property number 1 that we just studied. Now upon comparison over here I can say that x is equal to y, or upon comparison over here that I can say that x is equal to n minus y, which means that x plus y is equal to n. Hence proved that if NCX is equal to NCY, then there are two possibilities, either x is equal to y or x plus y is equal to n. Alright, I hope everybody is clear with this part. Now let's understand some remarkable points related to NCR. First point, whenever I am going to define NCR or NPR, so these are defined only for n belonging to the set of natural numbers, r belonging to the set of whole numbers, and n minus r is always greater than or equal to 0, which means n must be greater than or equal to r. So this is where we can define NCR or NPR. N must be set of natural numbers, r must be set of whole numbers, and n can be greater than or equal to r. Otherwise NCR or NPR cannot be defined. Also, if I say that what will be the value of NC0? NC0 is simply n factorial over n minus 0 factorial, that is n factorial, and 0 factorial. So this becomes equal to 1 because n factorial gets cancelled off and 0 factorial is already equal to 1. So NC0 is equal to 1. And if we calculate NCn, this is again n factorial over 0 factorial and n factorial. So this gives us again equal to 1. So basically NC0 is as good as NCn and they both are equal to 1. Which means that if I ask you what is the value of 5C0 or what is the value of 5C5, the answer is simply equal to 1. Third, if I ask you what is the value of NC1, this can be written as n factorial divided by n minus 1 factorial into 1 factorial. So this is basically n multiplied by n minus 1 factorial divided by n minus 1 factorial. So the answer comes out to be n. So NC1 is always equal to n. So if someone asks you what is the value of 10C1, so 10C1 is going to be what? 10. Alright, you must memorize these important points in order to save your time in examination. Whenever comes NC1, you can directly write it down as n. NC0 and NCn can be written down as 1. Alright, I hope everybody got till this point. Now let's move forward and solve a few questions that are based on the formula of NCR or the concepts of combinations. This question says, how many words with or without meaning, each of 3 vowels and 2 consonants, can be formed from the letters of the word involute? Now, since we are interested in segregating the vowels and consonants, we are first going to list down. In the word involute, how many vowels do I have? I, O, U and E. So we have I, O, U and E, 4 vowels. And apart from these, we have N, V, L, T. N, V, L and T. So there are 4 consonants. Alright. So out of these 4 vowels, we are required to first of all select 3 vowels, and this can be done in how many ways? 4C 3 ways. And out of these 4 consonants, we are required to select 2 consonants. This can be done in how many ways? 4C 2 ways. And I have multiplied them because we want the simultaneous occurrence of events. Now, this is the selection part of the question. We have selected vowels and consonant according to the demand of questions. But the question also says how many words can be formed. Now, in order to form the words after selection, we have to also arrange them. So, total we have 3 and 2, 5 letters, and out of these 5 letters, we have to arrange all of them in order to form a word. Now, this can be done in how many ways? We have to take the help of permutations. If we have 5 objects, they are going to be placed at 5 places in how many ways? 5 factorial ways. Alright, so this is arrangement. Alright, now we are done the total number of ways in which the words can be formed. So 4C3 is equal to 4 and 4C2 is equal to 4 factorial divided by 2 factorial, again a 2 factorial, multiplied by 5 factorial. Alright, so this gives us 24 multiplied by 5 factorial to give us the net answer as 2880 words. So total 2880 such words can be formed according to the demand of the question. Alright, so students, I hope everybody must have understood the concept of combinations and the questions that we have gone through. In our next class, we will be discussing some of the questions that have been asked in this chapter from the previous year's JEE mains examination. So this is it for today's class. See you.